Okay, so we were saying that from the previous part, we solved for the magnitude of velocity, which is perpendicular to the radius. So we know its direction also, since the angle between this velocity and the horizontal is equal to angle theta. So this angle here is theta. You can demonstrate this by several ways, or you say that these two lines are perpendicular to these two, so it's the same angle. Or also, if this is theta, this is 90 minus theta, and since here I have a right triangle, a right angle, this angle here will be theta. And these two are alternating angles. So I can demonstrate that the angle between the velocity and the horizontal is theta. And for projectile motion, all I need is to know the velocity magnitude and the angle of the initial angle to determine my unknown x. So my purpose is to know, given the velocity magnitude and the angle alpha or theta, what will be the value of x? You know that from projectile motion, I can determine the distance from this point. Okay, so I can determine what is the distance when I reached E. Can you tell me which equation you might use here in projectile motion?
يلي ما فيها تايم تبع tangent theta.
Exactly, very good. يلي ما فيها time. Y prime is a function of x prime. In this problem, I know if you want, I know the value of y of E, because if I consider my axis of projectile here at the initial position, I will call this is x prime, this is y prime. I have from projectile motion the relation between y prime and x prime. Okay, I know that y prime of E is equal to what? It's negative because I am below x prime axis, and it's equal to minus this distance here, this one. What is this distance? Look, I know the radius. The radius is equal to the radius at this location, which is 1 meter. Okay.
1 minus cosine theta.
You have that, yes, 1 times cosine theta, because the angle here is theta. So y prime E is equal to minus 1 cosine of theta. Okay. So since I know y prime of E, and I know for a projectile motion what is y prime function of x prime, everything is given for me. I know the velocity magnitude, I know the angle, so the only unknown will be, so I can write it function of x prime of E. The only unknown in this equation will be x prime of E, because I know the velocity VC, I know it, I know the angle theta, so I just replace in the projectile equation, and then I can calculate x prime of E. But keep in mind x prime of نعم
نحن بدنا الديستنس right؟
Yes. نحن ليك شو بدنا؟ بدنا الاكس كلها من هون لهون. The projectile motion حتعطينا this distance. We should
yeah, I know.
Yeah.
بدي كنت بشوف انه نحن طلعنا الانجل so we can use it على trajectory equation.
Exactly.
No?
أكيد. يعني أنت previous question اللي عطتك الماgnitude والانجل, you will use them as input بالfunction. لأن أنتم بتعرفوا بالبروجكتايل في عنا relation بين y prime و x prime, وهيدي الريليشن في بقلبها velocity magnitude at the initial state والangle. Since we know them, يعني صار عنا الفانكشن between y prime and x prime. So if you know
مش لقينا ال v0y.
نعم.
قصدي نحن ما لقينا
نحن ما لقينا ال v0y، ما لقينا ال v0y، لقينا ال v0. اوكي
اوكي
لقينا الفي 0 والانجل الفا او تتا اسمه هون. So whenever you know the magnitude والangle you have everything. يعني you can calculate V0x, you can calculate V0y. بس بقلب الفورمولا للy function of x تستعمل الماجنتيود V وبتستعمل الانجل تتا. اوكي
اوكي
So once you get x prime of E, x prime of E represents the distance from this point. To get x, you still need to add a distance to it. You should add to it plus this part. And what is the length of this part? Here. Let me clear the figure. نحن جبنا distance هيدا, okay? From the origin of projectile motion. We still, to get x, we still need to add this part. From geometry, what is the length of this part? مش قلنا انه هيدي 1. This is 1 meter. And the angle theta is here.
هي r cosine theta.
Sine. Okay? لأنه هيدا السايد is opposing the angle theta. The cosine theta هي this one. And this one is 1 sine theta. So I should add to the distance x prime of E. I should add plus sine theta to get the value of x that I asked for. Okay? Clear?
Yes, ma'am.
Okay. Another problem.
بس هون بتكون ال V negative ال VC.
لا, VC كماgnitude. Okay? You use VC كماgnitude. هلا الانجل هو النيجاتيف. الالفا, when you replace in the equation, instead of having a positive alpha, it's a negative alpha.
اوكي.
Okay.
دكتور يعني هي minus 1 times cosine theta هي الماينس للكوساين.
لا يعني أنا قصدي إنه أنت وقت تكتب الإيكويشن تبع when you write the equation of the trajectory الألفا الأنجل الألفا اللي نحن نحن عادة كنا على طول ناخد cases هيك صح؟ كنا ناخد على طول upward velocity. And this is the angle with the horizontal alpha. Okay?
أنا هيدا كان قصدي.
إذا كانت velocity like this ساعتها الألفا هو minus theta. يعني I replace بالequation instead of alpha I put minus of theta. Okay?
اوكي.
Okay. Another problem. A man having a mass of 75 kilograms sits in the chair which has been connected to frame BC. If the man is always seated in an upright position, determine the horizontal and vertical reactions of the chair on the man. At the instant, angle theta becomes equal to 45 degrees. At this instant, he has a speed of 6 meters per second, which is increasing at 0.5 meter per second square. So let us try to put what we know in this problem and what should we do to find our unknowns. So first, we have a man. The mass of this man is given. We can treat this man as a particle. M equal to 75 kilograms. And he is rotating around a fixed axis passing by point C. So the path of motion is a circle. So if I want to illustrate the path of motion of the man, it's a circular path. Now, they are asking to find the horizontal and vertical reactions of the chair on the man for an angle theta of 45 degrees. So when theta is equal to 45, I want to determine the component of the chair action on the man. So my system is the man. I will take the man, isolate it, and draw the free body diagram, which will represent forces acting on it. What are the forces acting on the man?
Weight.
Weight.
Of
First,
normal.
the weight, okay? And they are asking for the action of the chair on it. So the man is subjected to the weight and to the action of the chair. Now they want me to decompose the action of the chair into two components, one horizontal and one that is vertical, okay? So I can represent these actions. I will call them Rx and Ry. Now you can assume the directions as you like. You can put Rx to the left, you can put Rx to the right. It doesn't matter, because when you solve, if you get a positive result, this means that your assumption is right. If you get a negative result, this means that your assumption is wrong. Okay?
But
And
isn't there normal?
ما هي هون النورمال هي من التشير صح؟ The normal reaction مش هي من التشير؟
Exactly.
يعني هي
Exactly.
implemented in Rx Ry. Okay? So Rx Ry will represent the total reaction of the chair on the person.
هلا الشير هي perpendicular على الموشن دايما؟
التشير مش perpendicular على الموشن. No. يعني انت عندك what is happening انه at any يعني if you want your system is rotating يعني the chair will rotate. Okay, but at any instant you can divide the components of the chair into two components, one in horizontal, one in vertical. Okay.
Okay.
Now, in which frame you can think to work? You will work in Cartesian frame, or you will work in normal tangential frame.
UNUT.
Very good. Always, when you have circular motion, think about UNUT. Okay. If I want to work in UNUT, I should first draw my unit vectors UN and UT. If I go back to this figure, how is UN? How is vector UN?
Toward the center.
Very good. Towards the center of rotation. So directed from B to C. This is UN. How is UT?
Tangent to the trajectory.
Tangent to the trajectory. So it's perpendicular to BC, which is the radius. And no need to present UB here because no forces are acting along UB. And UB is just perpendicular to your screen. It is towards you or towards the screen. It's perpendicular to the vertical plane. And we don't need it here because no forces are acting along UB. So after I determine my UNUT, things becomes much easier. All I have to do is to project my forces. So let us represent UNUT on the free body diagram. Since this angle is 45 degrees, okay, so when you draw the vertical direction, since this is 90 and this is 45, so the angle here also will be 45. So UN is doing an angle of 45 degrees with Y, and of course also an angle of 45 degrees with x. Okay, so if I want to represent these vectors here, this is un. The angle is here 45, and this is ut. Also doing an angle of 45 with x. Now I'm ready to project my forces along un and ut. The first equation I can write is sum of forces along un is equal to man. Now, what are the forces acting along un? Let us project together. The weight has a positive projection on un. And since the angle is 45, I should do W cosine 45. So plus the weight cosine 45. This is the projection of the first force. Now, Rx, if you project Rx on un, it's also positive. And the angle also is 45. So plus Rx cosine 45. Now, for Ry, since I assumed Ry upward, then its projection on un, according to my assumption, is negative. So minus Ry cosine 45.
بس مش
Okay.
لازم تكون الرياكشن مع اليوتي. ليه حطينا ار اكس وار واي؟
لا، ليش بدها تكون الرياكشن مع UT؟ Why؟ ليش عندها two components؟ في يكون عندها component along UN و component along UT. Look، انت يصير فيها الروتيشن.
مش هي perpendicular على مع البادي، يعني بتكون perpendicular عليه؟
No. Look، انت بس يصير في motion depending on the motion، يعني depending on the speed of your system and its acceleration, if you change these تتغير الرياكشن direction. اوكي، يعني الرياكشن في يكون عندها component على UT وعلى UN. هلا فيها تثاقب انه for a certain position تكون zero على UN، بس مش always. لانه now when we will write the equation you will see that if I change the speed at B and the acceleration at B, the direction of the force will change. بيتغيروا ساعتها Rx و Ry. So it depends on the velocity and acceleration of your system. Okay? هون they gave you the velocity. They told you that at this position the velocity is 6 meters per second, increasing at 0.5 meter per second square. This number is what? The velocity increase represents what?
الاكسلريشن.
أي acceleration?
التنجنشال.
Very good. Tangential acceleration, which is dv by dt by definition. Okay? So if we change, يعني إذا كان decelerating بدل accelerating, بيتغير الساين يمكن ل one of the reactions. So the reaction direction will depend on the value of AT and the value of V. If you play with these values, the direction of your reaction will change. Okay?
Okay. Thank you.
Welcome. So this is equal, sum of n equals to man equals to the, you know that an is the velocity square. We are dealing at point B, يعني VB square over the radius. The radius is given, it's the radius of the circle. So it's given here, I think 20 meters, so over 20. So as you can see, the value of VB here that is given will affect the Rx and Ry. So if you change VB, this will accordingly change the reactions values. So this is my first relation. This is equation number 1. How many unknowns I have in this equation? Everything is given except the reaction components in X and Y. So I need to write another relation including Rx, Ry to solve a system of 2 equations with 2 unknowns. So since I already wrote the first relation, sum of n equals MAN, I can now continue with applying a Newton law in the tangential direction. So now I can write that sum of t is equal to MAT, and AT is given for you in this problem. It's equal to plus 0.5. And if it was decelerating, everything will change. So these values will impose the reactions Rx and Ry. So now I just replace AT by its value, which is 0.5, and the mass by 75. So this is equal to 75 times 0.5. Now please pay attention. Because they said increasing, so it's in acceleration, AT is positive. If they said it's decreasing at 0.5 meter per second square, then you replace AT by minus 0.5. Okay? Now, I should project my forces along UT. So this is equal to, first.
Sorry, miss.
Yeah?
بس فيك ترجع تفسري كيف عملنا projection لل RY
Yes, sure. Yeah, I will. Let me draw again the diagram. هلا حنعمل البروجكشن على UT, okay? بس نعملها على UT ترجع تفهم هي ذاتها لأنه. So you have the weight. You have Rx. You have Ry. 3 forces, okay? Now, how is UT? UT, for example, is doing an angle of 45 degrees with Rx. So you know the angle. As long as you know the angle, you can do your projections, okay? So this is 45, this is 45, and also if I extend the line here, this is 45. So the 3 forces are doing 45 degrees angles with UN and with UT. So هون it's an advantage to have 45 لأنه ما بتفرق cosine or sine. إذا كان مثلا هون 30, this one should be 60. So you should pay attention more for angles. But here, since all angles are 45, sine or cosine, it's equivalent. Okay. Now, how you do the projections? This is UT. Okay. For example, if you take Rx, you say, I will do the perpendicular projection from Rx to UT. It's pointing up in the positive direction. So the projection of Rx on UT is plus Rx cosine or sine 45. Okay. Now, for Ry, also, if you do the projection of Ry on UT, also it's pointing up. So also it's a positive projection. So plus Ry cosine 45. Finally, for the weight, if you project the weight on UT, it's pointing downward, opposing UT. So it's a negative projection. You do the same for UN, okay? So when you project on UT, what do you get? You get plus Rx. Since we used cosine before, so now it's sine. So Rx sine 45 plus Ry sine 45 minus W cosine 45. And in this way, you obtained a second equation relating Rx and Ry. So this is equation number 2. So we end up with 2 equations with 2 unknowns, which are Rx and Ry. Okay. Once you solve, you get the horizontal and vertical reactions of the chair on the person. This was the question.
Professor
Yeah?
سوري هلا قفزت بس ما كنت عارف عنها recitation
We
هلا
don't
صراحة.
have a recitation. It's another course.
This is not Mac 230.
No, يعني I thought that one was asking me if the problems are similar
So there is
similar
some
to Mac
student-
230. No, it's another
There's some
course.
student from Mac 230 now watching you guys.
It's fine. It's fine. No. Of course, no. We didn't introduce yet the course material.
موضوعنا. يلا
Okay.
thank you so much.
Fine, welcome. Okay. Any question before we move to another problem? Okay. Problem 4.
Thank you. Sometime,
Yeah.
what time are we now?
No.
What time بنخلص?
Yeah, 15 minutes nearly. Yeah, when this
Okay.
meeting will be over, will be done. Okay?
Okay, great, thank you.
Yeah. A smooth block having a mass of 0.2 kilogram is attached to A of the right circular cone using a light cord. If the block has a speed of 0.5 meters per second around the cone, determine the tension in the cord and the reaction which the cone exerts on the block. Neglect the size of the block. So in this problem, you have a block. It's attached to a cord to point A. And you have a cone having a revolution around vertical axis. So this will give for your block a circular motion. Your block will move around a circle. And the question is to find the tension developed in the cable and the reaction of the cone on the block. So whenever you have to calculate forces, of course, you will think about Newton law. Now, always select the appropriate frame. Whenever you see circular motion, think about UNUT. So the first step in this problem will be to draw the free body diagram of the block and to represent forces acting on it. Okay? So first, what are the forces that will act on my block?
Normal reaction.
Normal reaction of the cone.
Wait.
Weight. What also? Tension.
Light cord.
Tension of the cord. Okay. And what is the motion type? It's circular motion. Okay, so this is the circle of motion of radius. I can calculate the radius from geometry and I will calculate it together. So before projecting forces, what is essential is to establish frame UNUT. Okay, how is UN? You can look at this figure to help you. How is UN vector?
مش لل A.
زد
لا مش لل A لأنه السيركلر موشن منا هو
زد
البلوك عم يبرم around A or it's moving on this horizontal circle.
اوكي يعني
اوكي
مش
هو
perpendicular.
عم يبرم على الكون. The block is moving on the cone. So it's turning on a horizontal circle, this one. Okay, which is parallel to the base. So UN is directed towards the center of this circle. So it's along the horizontal line. So if I want to represent here UN will be a horizontal vector. So this is UN. Now, how is UT here? How is UT? In this figure, can you tell me how is UT?
لجوا
برافو. لجوا أو لبرا حسب الروtation. So if the rotation direction is like this, بيكون جاي صوبنا البلوك. So بيكون لبرا. In case it's turning in the opposite direction, بيكون لجوا. So here, if I take this direction of revolution, then UT is towards us. يعني perpendicular to the screen. So I can represent it by a dot with a circle. This is UT. So UNUT forms the horizontal plane. UNUT is in a horizontal plane. So how is UB?
لفوق.
Very good. UB is vertical because UB is perpendicular to the plane formed by UNUT. So UB is up. UB vector. Okay. Now, once I establish the frame UNUT UB, I can project my forces. So first, do I have any force along UT? Do I have any force along UT vector, which is perpendicular to the screen?
That's the way.
No.
No, the weight is vertical. It's not along UT.
Oh,
I don't
yeah,
have any
but-
force along UT. And this is expected. You know why? Because your cone is moving at a constant speed. So sum of t will give me 0. And as expected, then AT is 0 and the velocity is constant. And this velocity, this constant velocity is given to be 0.5 meters per second. Okay? Now, I move to equation along UN. So if I write sum of forces along UN equals to MAN. I can replace AN by V square over the radius of the circle. At the end, we'll calculate together geometrically this radius. The velocity is given. The velocity is 0.5. I will clear everything so you can see better the radius at the end. We'll calculate it. Okay. Now let us project forces. We have along UN first. The weight, as you can see, is perpendicular to UN. No projection. So we have projections of the tension and of the normal. But to be able to project T and N on UN, we need angles. We need to know what is the angle between T and UN. And once we know the angle between T and UN, we can deduce the angle between N and UN because T and N are perpendicular. The figure is a little bit complicated. Let us go back to analyze the initial figure. I will zoom a little bit. Okay, so if you look at your cone here, first, this is your tension. This is your tension force. And this is your UN direction, okay? If you want to find the angle between these two, you can look at your figure and say, I can calculate this angle. I will call this angle alpha, okay? How can I calculate alpha? I have this triangle here, that is a right triangle. And I know in this right triangle that this distance is 300 millimeter. And this one is 400 millimeter. So I can just write that tangent of alpha is 3/4. And then this will allow me to calculate the angle alpha. Plus, how can I find the radius of my circle? I can do several methods. I can apply similar triangles. You have these two triangles, the smaller one and the biggest one. Or also, after you calculate alpha, if you look in this triangle here, Okay, this is a right triangle. The hypotenuse is 200 millimeter. So you can say that the radius of your circle is simply r equal to 200 millimeter or 0.2 meters if you are working in meter, 0.2 times sine of alpha. So you can get your radius. Okay, once you get the angle alpha and the radius, now you can project. So this is my tension force. My tension force is doing, if this is alpha, okay, the angle between T and UN, this is UN, the angle will be 90 minus alpha. Okay, and for the normal reaction, as you can see here, because the normal is perpendicular to the tension, so if this is 90 minus alpha, this angle will be alpha. So now if I project on UN, UN is positive to the right. So I can have plus T sine alpha, positive projection on UN, while for the normal, the projection is towards the left, so it's a negative projection. So I do minus n cosine of alpha, because alpha represents the angle between the normal and UN. The weight is perpendicular to UN, no projection, 0, equals to MAN, which is M times V square, which is known, over the radius, which we calculated now. So this will give me equation number 1 between the two unknowns, which are the tension of the cord and the normal reaction. So all I need now is to write the second equation, which is the projection now along UB. Okay, we know that in UN, UT, UB, always sum of forces along UB is 0 because UB is perpendicular to the plane of motion. Now, UB is the vertical direction. So to project on the vertical direction, I have the weight which is downward, so minus W. Now, since the projection of T on UN was T sine alpha, you can automatically say that it will be T cosine alpha on UB, okay? So because this angle here is alpha. So when you project, you have a positive projection of T. So it's plus T cosine alpha, and also N has a positive projection on UB. So plus N, but now for N, because on UN it was cosine, on UB it is sine. So plus N sine alpha equals to 0. So now I end up with two equations with two unknowns. So I can get T and N. Okay, and we are done with this problem. Any question on this?